Our next speaker is Mr. Manuel Greisinger, who is Director of Global Distributed Cloud, where he leads global strategic initiatives to help organizations harness Google's cloud and AI capabilities at scale. He has extensive experience driving innovation and digital transformation, having previously held senior roles at Amazon Web Services, Intel, and IHSE Group. Manuel began his career as a technical sales engineer and holds a degree in microsystems and semiconductor engineering from the University of Applied Sciences in Regensburg, Germany. Mr. Greisinger.
Good morning, and thank you very much for inviting me. It's really a pleasure to be here. I'm delighted, and I'm happy to speak on behalf of Google. The topic we are discussing today, the convergence of digital infrastructure and nuclear energy, is not just an energy topic. It is the critical path for the future of the global economy. I'm here representing the digital infrastructure perspective, the hyperscale perspective. And to put it bluntly, we are currently building the engine of the 21st century, which is artificial intelligence. But as everyone in this room knows, an engine is pretty much useless without fuel. So the digital infrastructure community is here at the symposium because we have crunched the numbers and we have realized that nuclear energy is not just an option. It is an essential, non-negotiable component of our future fuel mix. Today, I want to share my perspectives on why we are here, what we are doing about it, and how we need to work together. Let's start with reality on the ground. You have seen in the headlines, data centers are becoming the fastest growing electricity consumers globally. But let me give you the specifics. Deloitte estimates that US data center consumption could quintuple, so fivefold, by 2035 already. We are looking at a US grid that needs about 400 gigawatts of new power by 2040, which is a 32% increase from where we are today. This demand is primarily driven by the big shift to generative AI. These workloads are fundamentally different from standard cloud computing as you know it. They are power dense, they are very latency sensitive, and they require absolute consistency. We cannot train the next generation of, for example, medical AI models on a grid that flickers. We need what I call clean, firm power. Electricity that is carbon-free and available every hour of every day. At Google, we have set a goal to operate on 24/7 carbon-free energy. This is an incredible high bar. We cannot achieve it with wind and solar alone, of course. We need a partner that runs when the sun isn't shining and the wind isn't blowing. For a long time, the tech sector's playbook was all about renewables only. That era is over, and we are now writing a new playbook. And I want to be clear about this. It's not just Google. The entire hyperscale sector is moving in this direction, as we've seen from previous speakers, sending a demand signal that nuclear is rejoining the center of US power planning. And we've seen a few of those examples before. Microsoft, for example, has signed a 20-year deal to restart 3 Mile Island Unit 1. Amazon has invested in Talon Energy's nuclear facility and is backing X Energy. Meta is partnering with Constellation, just to name a few. So why the sudden shift? It comes down to physics and math. Nuclear has a capacity factor above 92%. far outpacing any other carbon-free source. And for a data center that runs 24/7, that reliability is the difference between a working product and a failure. We are all realizing that to support the AI era, we must blend variable renewables with steady nuclear baseload. So how do we turn this interest into electrons? The digital infrastructure community is moving from a passive customer to an active partner, from our point of view. Historically, your industry has suffered from the first-of-a-kind problem. Projects were treated as massive, bespoke civil engineering tasks, which tended to be slow, expensive, and risky. We need to treat reactors like products. This is why Google signed the world's first corporate agreement to purchase nuclear energy from multiple SMRs with Kairos Power. We've seen it before on slides. And we aren't just buying one pilot. We are building what I call an order book. And here's the strategy. We are committing to a framework of up to 500 megawatts of capacity coming online between 2030 and 2035. This gives Kairos the certainty to iterate. They are using a molten salt cooling system with ceramic pebble-type fuel. This allows for low-pressure operation and simpler safety systems. And by ordering a fleet, they can learn from the first deployment and immediately apply those efficiencies to the second and the third and all the others that come. It is really an iterative development approach designed to drive down costs exactly the way it happened with, for example, solar panels before. But our engagement goes deeper than just buying power. We are also bringing our own superpowers to the table, which is AI and data. We know that 60% of nuclear reactor costs are tied to construction. This is largely a logistics and a data problem from our perspective. Construction management has historically relied on spreadsheets and fragmented paper documents. That's why we have partnered with Westinghouse to change this. We are integrating Google Cloud's AI with Westinghouse proprietary data to optimize the construction of their AP1000 reactors, 10 of which they aim to have under construction by 2030 already. We are using specialized AI models in that case. Hive is Westinghouse proprietary AI infrastructure, and Bertha is a generative AI assistant that has ingested 75 years of nuclear documentation. By combining these with WNexus, which is their digital platform for building information modeling and product lifecycle management, we can predict supply chain bottlenecks, optimize labor staffing, and sequence tasks to shave months of construction timelines. You can later meet Dr. Lou Martinez, the CTO of Westinghouse, who's also here, and she calls this energy for AI and AI for energy. To show you how committed we are to solving the energy equation, we are even looking beyond the Earth's surface. Some of you might have seen, but we just recently launched publicly a project called Suncatcher, which is a Google research moonshot. We are exploring space-based solar power networks equipped with our Google Tensor processing units, our TPUs. And the goal is to scale machine learning in orbit, harnessing the full, unfiltered power of the sun. We are already moving to the hardware phase in this project because we are partnering with Planet to launch 2 prototype satellites by early 2027 already, and to test radiation tolerance and data handling in space. While this is a very big future vision of ours, It proves that we are leaving no stone unturned. So I will close with this. The digital infrastructure community is ready. We are signing the contracts. We are deploying the capital. We are sharing our technology. But we cannot do it alone. My recommendation to this symposium is that we focus on speed and repeatability. To policymakers, we need licensing frameworks that recognize the inherent safety of new designs like molten salt reactors, allowing for fleet approvals rather than reviewing every single unit from scratch again. And to operators, engage with us not just as customers, but as technical partners. Let us help you digitize your construction and your operations. The future of AI depends on the success of the nuclear renaissance. So let's build it together. Thank you very much.